Batch treatment. Here we can see an example of a batch treatment. Let's say we have a class of process. We start it, and the first thing we do is place an order. When we place this order, we order a certain amount of items. After that, we wait in this process for sales to be made. So I started the process, I placed the order, and I purchased certain items A, B, C, and D. So I have 150,000 items A, 275,000 of item B, and so on. Okay, so these are the items I purchased. So this is the amount I can actually use during this process because these are the items I purchased. I don't have any more. So I wouldn't be able to manage a larger amount than what I have here. And here we have a sales process. So here someone makes a sale, and once the sale takes place, we deviate the information to this process here. So the information of the total amount of items sold is deviated to this process. So here we can see 50,000 items of the type A were sold. Besides, 175,000 items of the type B were sold, and so on. So when we deviate this information, these lines with information, to this process, let's say we have a system task or 10 or 15 different system tasks, it doesn't matter, that calculate the stock. So it crosses the information we have of the items that were sold, it crosses that information with the amount of items that we ordered in this process. Obviously here we can see we've ordered 50,000 items A, and this obviously doesn't reach the amount of items that we have purchased here. So there still is enough stock, and the flow is going to stop over here. Now later on, another process is triggered. Another sale is made. So here we sold more items. The flow enters here to this intermediate message event, and here we calculate the stock again with as many system tasks as we need. Obviously here in the example we just represented it with one, although in a real process we might need some more. And here we have a gateway that evaluates the stock again. Now, if we take a closer look, we can see that here in the type of item B we sold 150, and we had previously sold already 175,000. Okay, so the total of 175,000 and 150,000, it's greater than the items that we actually purchased. So we're trying to sell more than what we have. So what do we do here? We send the flow through this outlet of the gateway, and this deviator system task has to restart this process. Why does it have to restart the process? Because we need to place another order. We need to purchase more items in order to cover this new sale that was made. Okay, so basically the flow goes down, it deviates, and where does it deviate? It deviates to the start message event of the same class of process. So we know we can deviate from one process to another different class of process, but we could also deviate from one process, from one class of process, to another process of the same class of process. Okay, so here, since there wasn't enough stock, we're going to deviate not only the amount of items that were sold and that weren't available in stock, but we're also going to place an order so we can actually cover this new sale that was made. So we deviate the flow, a new order takes place. Once that's done, we stop the flow again. So what would happen if there's a new process, a new sales process that where someone places an order? To what process is it going to deviate? Obviously, it's not going to deviate to this one because there's no items left. All the information was deviated over here. So the next process that's triggered, let's say here we have process 191, 192. Well, the process 193 would be deviated to this intermediate message event. This is why it's important sometimes to store the reference of a certain process in a family, in a business rule, as we mentioned earlier. This way we can we can retrieve this information. We can grab this information whenever we need it, and we know the exact instance of a class of process that we need to deviate to. In this case, it would be the process ORD 8115. So this can be a continuous cycle. We can have our derived process. It can create another derived process that can continue managing all the source processes.